Okay, are these two triangles similar? How do we know? So we don't have any sides, so we're trying to try either angle or they're not. So I'm just going to eliminate these right away because I have no side information. So now what I want to do is find these missing angles. So I can do 180 minus 127, that's 60 plus 67. That gives me 53 here. So I have 53, 53, 60, and 60. That is enough for angle similarity. Okay, problem number 32, we want to say if the triangles are similar. So I want to take and start anywhere. So I'm going to go 5 and 7.5. And 5 and 7.5 would be the same again, so I don't need to repeat that. And then I'll do 8 over 12. So when you divide, this is basically 2/3. And 8 divided by 12 is 2/3. So they are similar. They would not be similar by angle. And then we don't have any angles, so they're going to be similar by side. In problem 33, we have similar triangles. So we want to find the height of the flagpole. So here's our flagpole. So you can start anywhere you want. If I start with X, I'm going vertical, the height of the flagpole to the height of the person. And then the shadow of the flagpole to the shadow of the... So I went large to small, large to small. So 12x would equal 48 times 5. And x would equal 20. So the height of the flagpole, 20 feet. Okay. Number 34. If these are parallel, then the sides are going to be in proportion. So we'll have 8 over x equals 12 over 18. So 12x equals 144. X is 12. For number 35, again, we have parallel lines. They cut off the sides in proportional parts. So 24 over x equals 36 over 12. When you cross multiply, 24 times 12 divided by 36, we get 8. For 36, we have an angle bisector. So the triangle angle bisector theorem says the side, or the bottom piece, 7.5 over 7.8, will be in proportion. I chose x because 7.5 came first. They're on the same side. And then 11.2. So again, cross multiply. 7.5 times 11.2, and then divide by 7.8. And we get approximately 10.8. And here we want to find the length of a missing side. This is a right triangle, so Pythagorean theorem. I have the hypotenuse, so I'm doing 13 squared minus 12 squared gives me 5. At this point, if you are in first or second hour geometry, the PACE and the COTOT, you may stop here. This is all that your exam will cover. Or we'll continue on. So now we go to the special rights. So if angle B is 45, this is 45, 45, 90. I want to know BC. So 5, and this would be 5 square root of 2. If you didn't do that, you'd have to do the entire Pythagorean theorem, 5 squared plus 5 squared. You'd get a decimal, and then you'd have to figure out if either of these was the right decimal. So knowing the special rights makes it much faster. For 39, this is again 45, 45, 90. We do 4 divided by square root of 2. But when we rationalize it, you get 24 square root of 2 over 2. And that divides, that's just 12 square root of 2. So again, you can take half of this times square root of 2. That is how you go backwards. And for number 40, special right, 30, 60, 90. So the short leg is 10. The long leg would be 10 square root of 3. And the hypotenuse is double the short leg. So I'm looking for x is 10 square root of 3. That's here. And y is 20.